This presentation aims to provide recommendations on procedures and training aspects of energy management in climb and in cruise. By energy management, we'll talk about the most significant one, the VMO-MMO accidents that the flight crew can easily notice in the cockpit by ECAM warnings and a speed variation. Also, this energy change could be a loss of speed that the flight crew can also notice on the airspeed. We'll see in this presentation how to prevent and how to recover from this energy change. In the first part, we'll have a look on the VMO-MMO prevention and recovery. In the second part, we'll talk about speed decay, and we'll finish by reviewing some recommendations on training and operational aspects. So let's start by overspeed prevention and recovery. Let's have a look on the overspeed prevention and recovery and its associated philosophy. The first step of this philosophy, when you experience an overspeed, is to first decrease the speed and the Mach target. The second aspect of this technique is to increase the drag. These two steps should allow to prevent from overspeed situation. If not successful, the flight crew may have to apply the golden rule number 4. It's to take actions if things do not go as expected. That means that take over and recover from the situation. Now, where to find these techniques? A few years ago, we proposed to have a look on the FCOM abnormal procedure part to read the prevention and recovery techniques to apply in case of overspeed. In addition to that, the recovery procedure part was presented in the quick reference handbook. However, it was not really adapted to the operations, so we decided to publish these two techniques in the flight crew technique manuals. In this FCTM, you can find the prevention and recovery part as a technique that the flight crew will have to apply by memory if an overspeed situation appears. Now let's have a look in detail on the technique. So first, the prevention. If the flight crew notices that the airspeed may fall into the red band and you will be in situation of a VMO, the first actions to do will be to keep the automation, autopilot and auto thrust. The second step to apply will be to select a lower speed and Mach, for sure, of course not below green dot, to slow down the aircraft. The flight crew will have to check if the two first actions are successful. If not, the speed brake extension will be possible to increase the drag. In the case of the prevention was not successful, the aircraft will enter into a VMO-MMO situation, and the first actions that the flight crew will have to take is to keep the autopilot and the auto thrust if already engaged. The second step will be to keep the speed brakes extended or even to extend full speed brakes as required by the situation. And finally, if required, the flight crew may have to set the thrust lever to idle to ensure that the engines are not accelerating. In the case of the first steps of the prevention and recovery procedure were not successful, the autopilot will disconnect due to the high-speed protection activation. This protection orders a nose-up to slow down the aircraft. Remember, the autopilot just disconnected, so you are in control of the aircraft. In this case, you will have to adjust the pitch smoothly and be careful because your order is added to the pitch up order. The second step will be to keep the speed brakes extended in order to increase the drag. Finally, when you recover from an overspeed situation, you will have to check the speed brakes and to retract them if required. In this case, you will have to be careful because if your speed is still close to the red band, retracting the speed brakes could create a new VMO-MMO situation. The second step will be to select an appropriate speed target with a margin to VMO-MMO. If the autopilot is disconnected, you will have to recover smoothly your flight path, mainly if you are at high altitude by slow inputs on the stick. And finally, to adjust the thrust, and if the auto thrust was disengaged, to pay attention to the engagement of the auto thrust and the auto thrust target that you have selected. So as a summary, overspeed may happen. It is still possible to prevent it. However, if it is not successful and you enter into a VMO-MMO situation, you have to remember two things to recover the situation. First is to keep the automation, the autopilot and the auto thrust. The second aspect is that if the autopilot is disconnected, if you have to take over, do it smoothly to avoid excessive pitch situations. Now let's have a look on the speed decay. The speed decay is a phenomenon that could be due to several things. First, the orographic waves, we'll see an example just after, and the associated downdraft. Another case of speed decay could be the jet streams and the tropopause change. Why this phenomenon could cause speed decays? It's because they have an impact on wind and temperature. We'll see in details some examples. First, the effect of the downdraft. If we take this scenario, an aircraft flying at a given flight level at a constant Mach, if the aircraft meets a downdraft, the speed will decay despite the fact that the auto thrust order maximum power at a given flight level, but the energy is not sufficient to maintain the cruise flight level. Associated to this pitch up order to recover from the cruise flight level, the energy is too low and the aircraft will descend and the speed will decay. Now let's have a look on the impact of the temperature. You should know these figures which modelizes the energy of the aircraft. To fly at a given airspeed, a level of thrust is required, and a level of thrust is available depending on the flight level. The green dot here represents the speed where the thrust is minimum. According to the flight level, the thrust available has a range. When flying at a cruise flight level, the thrust use is optimized to fly at a maximum speed, very close to the maximum of thrust available and the thrust required. According to the energy needs, the thrust required may vary, but it should remain in the blue envelope. Now, if we imagine that the temperature suddenly increases, the thrust available to fly at a given airspeed decreases, and the thrust available is lower. Therefore, the margin to maneuver in terms of energy is reduced. If we add to this phenomenon a wind gradient, for example, the aircraft energy may not be enough to maintain the current airspeed target, and in this case, the aircraft speed will decrease because the energy is not enough. Now, if we have a look on the effect of the wind. If we take this scenario, aircraft in flight level at constant Mach, if an aircraft meets a jet stream, due by a heading change, for example, it could create a headwind decrease. In this case, the equation between the ground speed and the trail speed changes. The auto flight will try to compensate this energy change, and in this case will reduce the energy. In this case, the speed will automatically decay. So here this is a natural phenomenon due by the jet streams. So what to do in this case? So the first thing to know and to prevent is to know your rec max flight level. The second aspect is to monitor the temperature and the wind speed as much as possible. If the speed decay occurs, and even below green dot, the recovery action will be simple. As the energy of the aircraft is not sufficient, the idea will be to descend to a flight level to regain some energy. When it is successful, the idea will be to take some margin regarding the rec max halt to be sure that the level of the energy of the aircraft will be enough. Now let's have a look on some recommendations. So as we explained, the weather conditions plays a role on the energy change. It is possible to prevent it. Why? By preparing the flight, by reviewing the tropopause changes, the location of the jet stream, and the turbulences. Another point is to anticipate the potential temperature changes by having a look on the computerized flight plan and the waypoints where you can expect some temperature changes. You can compare these values on the weather forecast and to be able to anticipate these temperature changes. Another point is during the flight. It's not a question of anticipation, it's a question of preparing the potential energy change by checking the cost index, having an impact on the aircraft energy, by knowing your X-max flight level, and by knowing at any time your aircraft energy, by monitoring the speed trend and your current thrust. How to find this recommendation in the Airbus documentation? In fact, you may have a look on the flight route technique manual to have a brief on VMO situation and to prevent and to recover from these situations. In these techniques, we will remind what we have seen at the beginning of this presentation. So first will be to keep the automation, to increase the drag, and to control the aircraft by smooth inputs. Now, how to build an efficient training to cope with this situation. Further to the operator revision number 3, Airbus published an operations training transmission called Undesired Aircraft States Training Recommendations. We considered, based on the operator recommendation, that a sudden change of energy could be considered as a non-desired aircraft state. In this document, we summarize how to build an efficient training to prevent, to recognize, and to recover from sudden energy changes. So first, the idea would be to provide to the trainees a knowledge level regarding the prevention and the recognition by briefing on the automation, the energy management, the flight envelope and the environment, meaning the weather conditions and their impact on the flight. The second aspect that we provide is to perform an efficient training and to apply procedures and techniques to recover from the different energy change situation. Let's have a look on the example that Airbus provided on 320 on their training center. So we propose to perform exercises during each recurrent training program. And the idea would be to perform exercises at high altitude where the energy is limited, and to perform some pitch and thrust flying in order that the flight crew feels the aircraft energy. By performing this exercise, we will ask also that the role of pilot monitoring is briefed, and the idea will be to monitor the flight parameters and to inform the pilot flying that something is happening. The other idea will be to reinforce the communication between the two pilots and to communicate on divergence on the flight parameters. And the idea will be to perform these exercises with and without automation in order to cope with all situations. So to summarize this presentation, we believe that the anticipation and the continuous monitoring of the aircraft energy is key to prevent sudden energy change and associated VMO accidents or speed decay. Airbus, we provide techniques to prevent and to recover from high and low energy states. Here we focused on VMO, MMO accidents and speed decay, but we cover also low energy situations. Everything is provided in the flight crew technique manner. And finally, and also this is a key point, the training is essential in order for the flight crew to be able to prevent, to recognize, and finally to recover from divergent energy.